welcome to the next edition of the BriefingsDirect podcast series. I'm Dana Gardner, Principal Analyst at interoperate Solutions, your host and moderator for this ongoing discussion on the latest insights into data center strategies. As 2020 ushers in a new decade, the forces shaping data center decisions are extending compute resources to new places. With the challenging goals of speed, agility, and efficiency, enterprises and service providers alike will be seeking new balances between the need for low latency and optimal utilization of workload placement. Hybrid models will therefore include more distributed, confined, and modular data centers at or near the edge. These are but some of the few top-line predictions on the coming state of the modern data center design. Stay with us now as we examine with two leading IT infrastructure executives how these data center variations nonetheless must also interoperate seamlessly from core to cloud to edge. Here to help us learn more about the state of data centers in 2020 are Peter Panfil, Vice President of Global Power at Vertiv. Welcome, Peter.
Hey, how you doing, Dana?
I'm doing great. We're also here with Steve Madara. He's Vice President of Global Thermal at Vertiv. Welcome, Steve.
Thank you, Dana.
All right, the world is changing now in 2020. Organizations are foregoing just the debate around hybrid and on-premises and public cloud. Tell us why we need to think about the architectures and hybrid computing a little bit differently. Let's start with you, Peter.
We noticed a trend at Vertiv in our customer base, and that trend was towards a new generation of data centers. We've been living with distributed IT client server data centers moving to cloud, either a public cloud or a private cloud. And what we're seeing is the evolution of an edge-to-core, near real-time data center generation. And it's really being driven by this devices everywhere, connected all the time model that all of us seem to be going to. And so when you're in a near real-time world, you've got to have infrastructure that supports your near real-time applications. And so this is what these C-level folks are the challenges they're facing. I refer to it as a pack of dogs chasing them. The amount of data that's being generated, the applications that are running remotely, the demand for, number one, availability, number two, low latency. Nobody wants the spinning dial anymore. And number three, cost. Drive costs down as much as you possibly can. This is what's really changing how they're approaching their critical space.
And so a new equilibrium is emerging of some sort. How is it different from the past?
Dana, this is Steve. If we go back 20 years ago, history, we look at, everything was centralized at enterprise data centers. Then we decided to move it decentralized. And then the move came back to centralized. And then we saw a move to colo as people decided that's where they could get lower cost to run their apps, and then to the cloud, as Peter said earlier. And along the lines of just the number of devices connected locally, and Cisco's been quoted by 2020 that's going to have 23 billion connected devices, and over half of those are going to be machine-to-machine communications, which, as Peter mentioned earlier, the latency is going to be very, very critical. An interesting read is Michael Lewis's book, Flash Boys, about the arbitrage that's taking place just with the latency, at the stock market. So I think we're going to see more move to the edge. The edge could be anywhere between a 250 kilowatt facility, 500 to maybe up to a megawatt. And I think it's going to be multi-tenant because it's going to be able to be in these large cities. There probably could be 20 or 30 of these edge sites that are hosting different applications for customers. I also think this move to the edge is also going to provide IT resources to a lot of underserved markets that really don't have compute, especially in emerging countries.
Yeah, I wanted to see why speed is important. We've been talking about this now for a few years, but it just seems like it continues to ramp up the need for speed and go to market, go to value rapidly. What's driving that?
So there's really more than one speed. And yeah, I know it sounds strange, Dan, this is Peter. When we talk about speed, there is speed of response of the application. That's something that all of us demand, speed of response of the application. What that says is that I've got to have low latency in terms of the transactions that I'm performing with my data or with my IT application. So there's that speed. There's the speed of the actual data being transmitted. There's also speed of deployment. When Steve talked earlier about centralized cloud deployments in these core data centers, your data might be going over a significant distance, hopping as it will along the way. Well, if you can't live with that latency that gets inserted in there, then all of a sudden you've got to start taking the IT application and putting it closer to the source and consumer of the data. So there's a speed of deployment from core to edge that happens. And then the third speed is you got to be able to have low first cost, high asset utilization, and rapid scalability. So that's a speed of infrastructure adaptation to what the demands for the IT applications are. So when we say speed, I often say, well, it's speed, speed, and speed. And by the way, it's speed. And so what you're trying to do is you're trying to say, okay, if it's all about speed, what speed am I talking about? First, it's the data IT. Well, once I've got data IT speed, how did I achieve that? I did it by deploying fast in the scale that I needed for the applications. And by the way, at a cost and a reliability that makes it tolerable for the businesses to be able to go after that kind of deployment.
So I guess it's speed cubed, right?
At least speed cubed, because many times I wish, Steve, if we had a nickel for every time one of our customers said speed, we wouldn't have to work anymore. They are consumed with the different speeds that they have to deal with, and it's really the demands of their customers.
All right, so Vertiv for years has been looking at the data center of the future and making some popular decisions around what to expect, and you've been rather prescient, so we want to continue that trend, and you've identified several areas that you think 2020 is going to see of the manifestation of them. So let's go through those trends. Steve, let's start with you with hybrid architectures going mainstream. Why did you identify that, and what do you mean by hybrid architectures changing and going more mainstream?
As we look back again, as I said, if we look at history of where we've gone from centralized to decentralized and going to colo and cloud applications, it really gets to the evolution here of all the IoT sensors, the 5G, the smart cities, the autonomous car. More and more of the data is just being generated and will need to be processed locally. A lot of the machine-to-machine type applications. So when we talk about the hybrid, we've got to get very, very close to the source as far as the processing is concerned. And I think that's going to be the large evolution that's going to drive the hybrid applications where there's going to be processing down at the edge as well as some centralized applications, whether it's in cloud or hosted in colo application.
Yeah, Steve. So you and I both came up through the ranks in terms of critical space. I can remember when the data closet down the hall, all it was a communications matrix. Its intent was just to get communications from wherever we were to wherever our core data center was. Well, now, number one, the cloud's not going away. Number two, enterprise isn't going away. What the enterprise is trying to do is they're trying to say, okay, I'm going to take my secret sauce, I'm going to put it in an edge data center, I'm going to put the compute power as close to my consumer of that data and that application as I possibly can. And then I'm going to figure out where the rest of it's going to go. If I can live with the latency that I get out of a core data center, I'm going to stay in the cloud. If I can't, I might even break up my enterprise data center into smaller micro data centers that give me even better response. Dana, I think it's interesting that there was a recent wholesale market summary published that said that the difference between the smaller and the larger wholesale deals widened. So what that says is the large wholesale deals are getting bigger, the small wholesale deals are getting smaller, and that the enterprise-based demand, and this particular report broke the enterprise-based demands into deployments under 600 kilowatts, it focused on low latency and multi-cloud access. So what that really tells us is that our customers, the users of that critical space, are trying to take their IT appliances and put them as close as they can to their customers, eliminate the latency, respond with speed, and then figure out how to mesh that edge deployment in with their core strategy.
Right, that sounds spot on. So our second trend does get back to this speed cubed notion. And I've heard people describe this as a new arms race because while it might be difficult to differentiate yourself when you're all using the same set of public cloud services, you can really differentiate yourself in how well you can conduct yourself in speed across these different dimensions of speed. So let's go to trend number 2, and I'll open this up to both of you. What kind of capabilities across your technologies will make differentiation around speed work to your advantage as a company?
I was with an analyst just earlier this week, and I said, the new reality is not that the big will eat the small. It's that the fast will eat the slow. And any advantage that you can get in speed of application, speed of deploying those IT assets, or speed of, I'll call it morphing the data center infrastructure or critical space infrastructure, that speed, what it does is they're trying to improve their capital efficiency. I don't know what other term to use for it, but basically what many customers have told us, Steve and I are in meetings quite often with folks at the C-level who are saying to us, I got to shorten the period of time between the time I decide to spend money on the asset and the time that asset starts creating revenue. So you got to work with me. Help me be creative. Help me be creative in lowering my first cost. Help me be creative in increasing my asset utilization. Help me maintain my reliability because holy cow, if my application ever goes down, I am out of business. And then figure out with me how to manage things like supply chain and forecasting, which is really difficult to do in this market, and help me to be as responsive as I possibly can to my customers.
To add to that, Peter, the forecasting and the understanding of all the new applications that are coming online, whether it's AI or 5G, and then the CIO needs to decide where they need to put those applications. Are in the cloud? Are they at the edge? Technology is changing so fast that nobody can predict far out into the future as far as, where I need that capacity and what type of capacity I need. So it really comes down to being able to put that capacity in the place where I need it, right when I need it, not too far in advance. Again, I don't want to spend the capital because I may put it in the wrong place. And, so it's got to tie the demand with the supply. And that's what's really key as far as the infrastructure. And the other element I see here is technology is changing really fast, even on the infrastructure side. We are constantly on our equipment making improvements every day, either making it more efficient, lower cost, more capability. And if you put capacity in today that you're going to use that you really don't need for a year down the road or 2 years down the road, you're not taking advantage of the latest, greatest technology. So really it's coupling the demand to the actual supply of the infrastructure. And that's what's really key. The other is many of these large, especially in the colo market, many of these companies their financial structures are real estate investment trust. And as a result of that, they need to tie basically revenue with expense tighter and tighter and capital spending. And so that's kind of another driver.
That's a good point, Steve. So Dana, one of the things that we say we see this as a trend, we took it seriously. And in large power, we redesigned our entire large power portfolio specifically to be able to address this demand. Previous generations were a generation where the UPS was built as a complete UPS. The new generation is built as a power converter plus an I/O section plus an interface section that can be rapidly configured to the customer order. In some cases, put into a vendor-managed inventory program where we would Kanban pieces of that assembly so that we can respond quicker. So we really were forced to change our business model. We were forced to change our business model in such a way that we could respond in real time to these kind of these capacity demand changes.
And to add to that, we're having to put together more and more modules and solutions where we're bundling the equipment to deliver it faster so that you don't have to do testing on site or assembly on site. Again, there are solutions that we're putting together to help the end user address the speed of the construction of the infrastructure. I also think it ties in, and this may be a subject we'll talk about later, is the relationship that the end customer will have, or the person that owns the infrastructure has, with their supply base and the relationships they have to build it. As Peter mentioned earlier, the ability to do stocking inventory, having parts available on site to go fast.
All right, so we've got this need for speed across multiple dimensions. We're looking at more hybrid architectures up and down the scale, from the edge to the core on-premises to the cloud. And we're also looking now, of course, at crunching more data and making real-time analytics part of that speed advantage by being able to have intelligence brought to bear on our business decision-making as fast as possible. So what's going on now with this edge? Even if we've got sort of average rack density remaining static, how will perhaps high-performance computing help make this analysis equation work to the business outcomes advantage? Let's start with you, Steve.
So what I see is the development of AI applications, machine learning, what could be called deep learning, that is really evolving here. Many, many applications, that are requiring these high performance compute systems. We're seeing these in the areas of defense. We're seeing it in gaming. We're seeing it in the banking industry, or people just doing advanced analytics and tying it to maybe a lot of these sensors we talked about, for manufacturing. So we're seeing this. It's not widespread. It's not across the whole enterprise or the whole data center. They're unique applications. What I hear in a large data center, especially from the banks, that I need to put up these AI applications. It could be a 30 or 40 or 50 or 60 kW rack, but I only have 3 or 4 of those in the data center. So it's not the whole data center. So the end user needs to decide, how do I tune or adjust my facilities to accommodate this small pod, if you want to call it, of high density. And if they're in their own facility, if it's an enterprise that has their own data center, they need to decide how they're going to facilitize in that area for that type of equipment. What we're actually hearing is from a lot of the colos, hosting facilities, that have customers that are saying, hey, I'm going to be bringing in the future here, a couple racks that are very high density. And a lot of these multi-tenant data centers are saying, oh, how do I provision for these? Because my data center really was laid out for this average of maybe 8 kW per rack. Now, how do I manage that? Especially data centers that maybe didn't have chilled water. So what we're seeing is the need to provide potentially chilled water that would go to a rear door heat exchanger on a rack. Could be chilled water that would go to a rack for chip cooling applications. And again, but it's not the whole data center. It's a small segment of the data center. So questions of how do I do that without overkilling in the infrastructure I need to build for this.
And Steve, do you expect what you're seeing in those small pods in the data center to make its way out to the edge when people are starting to do more data crunching out there for those low latency issues where you can't move the data to a data center? Do you expect to have this trend, in a sense, get more distributed?
Yes, I would expect this will be both in their enterprise data center. If they're in the cloud, I think you're going to see it in enterprise and cloud, and you're going to see applications developed here that are going to be out at the edge application because of the requirement for latency. You think about the autonomous car, none of us know what's going to be required there for that high performance processing, but I would expect there's going to be a need for that down at the edge.
Okay, Peter, looking at the power side of things, when we look at the batteries that support uninterruptible power supplies and making sure that things remain mission critical regardless of external factors, what's going on with batteries? How will we be perhaps using them differently in the modern data center?
That's a great question. Battery technology has been evolving at an incredibly fast rate. It's really being driven by the electric vehicle explosion. I shouldn't say explosion. The application of electric vehicles. What that's bringing into the market is batteries that, number one, have a size and weight advantage. All right, you can't put a big, heavy block of batteries in a car and hope to have it perform the same way. It also gives a life expectation. So in data centers used to have to make a decision between long life, high maintenance wet cells and shorter life, high maintenance VRLA batteries. In step, the lithium ion batteries and thin plate pure lead batteries. And what's happened is the total cost of ownership has started to become very advantageous for these batteries. Our sales leadership lead sent me the most recent total cost of ownership. And if you look at the TCO between either thin plate pure lead or lithium ion batteries versus more traditional VRLA batteries, the total cost of ownership is a winner chicken dinner for the LIB and for the thin plate pure lead. In some cases, over a 10-year period, the total cost of ownership is a factor of 2 lower for LIB and thin plate pure lead. So where in the cloud generation of data centers, it was all about first cost. In this edge to core mentality of data centers, it's about total cost of ownership. There's other levers that they can start to play with too. So they've got life cycle and operating temperature that used to be really a limitation. Nobody in a data center wanted their systems to go on the battery. They tried to let everything they possibly could to not have their systems go on the battery because the potential for shortening the life of their batteries or to experience an outage. Today, we're starting to develop applications that will actually take advantage of the fact that not only lithium-ion batteries, but also pure lead batteries can increase the number of cycles. Once you increase the number of cycles, you can start thinking about deploying smart power configurations where I'm not just putting in the critical infrastructure for that very short period of time where the utility fails, but I now start to put in a critical infrastructure that can help me offset cost. If I can reduce utility at peak demand periods, or I can reduce stress on the grid at specified times, then all of a sudden it's not only a reliability play, but it's also a revenue offset play. And so we're seeing more and more folks talking to us about how they can apply these new energy storage technologies to be able to change the way they're thinking about using their critical space. The other thing that used to happen was folks used to think the longer the battery time, the better off I was because it gave me more time to react to issues. Now what's happening is folks that really know what they're doing, they are going with runtimes that are tuned to their operations team's capabilities. And so if my operations team can do a hot swap over of an IT application, either to a backup critical space application or to a redundant data center, then all of a sudden I don't need 5, 8, 10, 12 minutes of runtime. I need just the bridge time. I might need 60 seconds, 90 seconds, 120 seconds. All of a sudden, now if I can have these battery times tuned to the operations capability, and I can use the batteries more often or in higher temperature applications, then I can really start to impact my total cost of ownership and make it very, very cost effective.
Yeah, it's very interesting. It's sort of an analog to hybrid computing, right? We can either go to the cloud or the grid, or we can go to on-premises or the battery, and then we can start to mix and match intelligently. So that's really exciting. How does that perhaps impact issues like sustainability and the important issues that are arising around conserving energy?
That's a really good question that we are having conversations with our key accounts with virtually every day. And so what they're saying is, I'm going to eventually not make smoke and not make steam. What I want to do is I want to limit the number of times I force my system to go on to generators. So I might put more battery in certain more lithium-ion battery or thin plate pure lead battery in certain applications, because if my total cost of ownership is half of that of VRLA, I could potentially put in twice as much, have the same cost basis, and get that economic benefit. And so from a sustainability perspective, what they're also looking at is saying, okay, I might need at some point in the useful life of that critical space to not draw what I think I need to draw from my utility. I need to limit the amount of power that I'm going to draw from that utility. Today's data centers, I will just tell you, and this is not a criticism, I love all of you out there that are designing and deploying data centers. but most of them are designed for the peak applications. Wouldn't you say, Steve? Most of them are designed for the peak applications. And so what these changes allow them to do is to design more for the norm of the application. So number one, they put in less infrastructure. They have the potential to put in less battery. They have the potential to right size their generator to the size of the generator that they need. Same thing on the cooling side, to right size the cooling to what they need, not to the extremes of what that data center is going to see. So from a sustainability perspective, so the best example I gave to a user is, we used to talk about, is the glass half full or is the glass half empty? What we're really talking to them about is there's just too much glass. Let's right size the glass to what is filling it. And once we right size the glass to what is filling it, then all of a sudden, all of the other things you have to do in support of that infrastructure are reduced.
And this is Steve. Let me maybe add something that's really more of a question for Peter to comment on, is as we start to look at these edge applications, many of these applications at the edge will not have backup generators and will have alternate energy sources and will probably be taking potentially more hits to the battery. And isn't the lithium ion really a better solution for that?
Yes, Steve, it sure is. And so what we will see is customers with an expectation of a path to sustainability, a path to an energy source that is not fossil fuel based, that could be a renewable energy source. They realize that they might not be able to deploy that today, but as they deploy what I call foundational technologies that allow them to take advantage of it, if I can have an energy source, a lithium-ion battery, for example, that stores excess energy, allows me to buy low, sell high, allows me to absorb energy at times when I'm creating more than I need, then all of a sudden I consume that energy on the other side. It's better for everybody.
Well, it's really quite a shift. We're going to an era where we have this flexibility, this agility. We can do it at speed, and we can optimize utilization to reduce our total cost. But the thing is that varies from region to region, and there are some areas where compliance is a top requirement. There are others where energy issues are a top requirement because of cost. So what's going on in terms of global cross-pollination? Are we seeing different markets reacting to their power and thermal needs? Do we have a architectural panoply, a sort of spectrum that is suitable to different markets? And how is that shaping the future? Let's start with you, Steve.
Well, if you look at the size of the data centers around the world, probably the data centers in the U.S. are across the board much larger than what we would have in Europe, and what's in Europe is much larger than what we would have in other developed countries. So there's a couple things, as you mentioned, energy availability, cost of energy, the size of the market, and the users that it serves. We may be looking at more edge data centers in very underserved markets that have been in more underdeveloped countries. So you're going to see the size of the data center and the technology used potentially different to fit more the needs of the specific markets. Yes, I think they're across the globe. Certain regions will have different requirements with regard to security and sustainability. There may be unique technology that is in one region of the world or not. But I really see this as, even though we have all of these potential differences that really are to meet the end user needs to right size the IT resources in that region, I would really almost also say, we're more common than we are different in many respects. We all have needs for security. We all have needs for efficiency. It may just be different degrees.
And there's different regional agency requirements. There's different governmental regulations that these companies have to comply to. And so what we find, Dana, is that what our customers are trying to do is they're trying to normalize their designs. I won't say they're standardizing their design, because standardization says I'm going to deploy it exactly the same way everywhere in the world. I'm a fan of KitKats, and KitKats are not the same globally. They vary by region. The same is true for data centers. So when you look at how the customers are trying to deal with the regional and agency differences that they have to live with, what they find themselves doing is trying to normalize their designs as much as they possibly can globally, realizing that they might not be able to use exactly the same power configuration or exactly the same thermal configuration. But we also see pockets where different technologies are moving to a forefront. For example, China has data centers that are running at high voltage DC, 240 volts DC. We've always had 48 volt DC IT applications in the Americas and in Europe. Customers are looking, again, three things: speed, speed, and speed. And so when we look at the application, for example, of DC, there used to be a debate: is it AC or DC? Well, it's not an or, it's an and. Most of the customers that we talk to, for example, in Asia that are deploying high voltage DC have some form of hybrid AC plus DC deployment, and they're doing it so that they can speed their application deployment. In the Americas, the Open Compute Initiative, OCP, that deploys either 12 or 48 volts at the rack, I look at it very simply. We've been seeing a move from 2N architectures to N+1 architectures in the power world for a decade. This is nothing more than adopting the N+1 architecture at the rack level versus the 2N architecture at the rack level. And so what we see is when folks are trying to, number one, increase their speed, number two, increase their utilization, number three, lower their total cost, they're going to deploy infrastructures that are most advantageous for either the IT appliances that they're deploying or for the IT applications that they're running. It's not the same for everybody, right, Steve? You and I have been around the planet way too many times. You're a million miles, or so am I. It's amazing how, while a city might be completely different in a different time zone, once you walk into that data center, how very consistent they have gotten, even though they have done it completely independently from anybody else.
All right. Well, thank you, Peter. So as we're running out of time and we want to kind of put a halo around these multiple trends we've been discussing, maybe it kind of boils down to that need to preserve speed to value, but also to be managing your costs and utilization. So what is there about these multiple trends that people can consider when it comes to getting the right balance, the right equilibrium between total cost management and that all-important speed to value? Let's start with you, Steve.
Well, I think there's a number of discussions. I think when we look at cost, everybody's trying to drive costs down. The more you can drive the cost down of the infrastructure and the IT costs, what it does is it allows you to develop more more applications that were on the edge as far as whether it was cost effective to do it. So I think we're seeing a very large rate of change of driving costs down. I think that some of the findings that we've seen over the years is we've got a lot of stranded capacity still out there in the marketplace and stranded resources. And I think people are making decisions that, I can take that cost down without impacting risk. I can do it faster. I think the other element as we talk about speed is Peter mentioned standardization. I would say standardization's there, and that helps drive speed, or whether it's normalization or similarity. I think the thing at the end of the day that allows people to move fast is kind of repeat what they're doing instead of, what we call snowflake data centers, where every new one is different, okay? And what that repeating allows you to do is to build a supply base that you have now what I would call a supply-based ecosystem, where everybody has the same goal and knows what to do and really can be partners in driving out costs, can be driving speed. I think those are really, as I see, some of the key elements as we go forward.
Peter, when we look to that standardization with flexibility and higher utilization, you also perhaps allow for more seamless communication from core to cloud to edge. How does that cut across these? Why is that important that we don't not only strand resources, but that we add intelligence and seamless communication among and between all these different aspects of a distributed architecture?
When we talk about normalizing designs globally, what happens is what they'll do is they'll take a look at the regional differences. They'll sort out what the regional differences have to be. They'll come in and work with us on first articles that they'll put a proof of concept, or some folks call it a SOAP deployment. And out of it comes a consistent method of procedure. So when we talk about managing the data center effectively and efficiently, first of all, you got to know what you've got. And second, you got to know what it's doing. And so what we're seeing more and more of is folks that are, if they can normalize their designs, they can start to get some consistency in the way they apply them. They can get consistent methods of procedure. They can then start looking at how much of their available capacity from a design perspective they are actually using, both on a normal basis and on a peak basis. And then they can determine how much of that they are willing to use. I mean, we have some customers who are very risk averse, very, very risk averse, will stay in the 2N world, which is a 50% maximum utilization. We applaud them for it because they are not going to miss a transaction. There are others who will say, I can live with the availability that an N+1 architecture gives me. I know I'm going to have to be prepared for more failures. I'm going to have to figure out how to mitigate those failures. So they're working constantly at figuring out how to monitor what they've got and figure out what that equipment is doing and how they can best optimize the performance. So we talked earlier about battery runtimes, for example. Sometimes they might get shorter, sometimes they might get longer. As these companies get into this step and repeat, as Steve called it, step and repeat function, they're going to get consistency of their methods of procedure. They're going to get consistency of how their, I'll call it their operations teams, run their physical infrastructure. They're going to start thinking about running their equipment in ways that is non-traditional today, but will become the norm in the next generation of data centers. And then they're gonna look at us and say, okay, now that I've normalized my design, can I use kind of rapid deployment configuration? Can I put it on a skid? Can I put it in a container? Can I drop it in place as a complete data center? Do I have to really build it, one piece of equipment at a time and stitch it all together? The question that you asked about monitoring, it's interesting because we talked to a major MTDC just last month. Steve and I were visiting them at their site, and they said, you know what? We spend an awful lot of time figuring out how our building management system and our data exchange happens at the site. Could Vertiv do some of that in the factory? Could you configure our data acquisition systems? Could you test them there in the factory? Could we know that when the stuff shows up on site that's doing the things that it's supposed to be doing instead of us playing hunt and peck to figure out what the issues are? We said, of course. So we're adding that capability now into our factory testing environment. So what we see is a move up in the evolutionary scale. Instead of buying separate boxes and having dorm room data centers, what we're seeing is they're buying solutions, and those solutions include both monitoring and controls. Steve didn't even get a chance to mention the industry-leading ICOM control for thermal. These controls and these monitoring systems allow them to increase their utilization rate because they know what they've got and what it's doing.
All right, last word to you, Steve, and we're just about out of time. It certainly seems to me with all that we've said today that the data center status quo just can't stand, that change and impact for improvement is inevitable. So let's close out with your thoughts about why people shouldn't be standing still. It's just not acceptable.
I think at the end of the day, the IT world is changing rapidly every day. New applications, whether the application has to be in the cloud or down at the edge. And I think the IT world needs to be able to adjust to those needs. They need to be able to be cognizant of the cost structure, and there's always a demand to drive costs down. This is a world and an environment that's changing every day, and if we don't change with it, we don't stay up with it, if we can't, especially as suppliers, meet the requirements of our customers to improve what they do in everyday life or everyday operation and the next build of everything, things aren't going to work out and somebody else is going to take over.
Remember, it's not the big that eat the small, it's the fast that eat the slow.
Yes.
And so what I've been telling a lot of folks is go, dog, go. You got to go. Technology's there for you to cut your costs, improve your speed, and increase your utilization. Let's do it.
Otherwise, somebody else is going to do it for you.
All right, well, very good. I'm afraid we'll have to leave it there. We've been exploring the forces shaping data center decisions and how that's extending compute resources to new places with the challenging goals of speed, agility, and efficiency. And we've learned how enterprises and service providers alike are seeking new balances between the need for low latency and optimal utilization of workload placement. So please join me in thanking our guests. We've been here with Peter Panfil, Vice President of Global Power at Vertiv. Thank you so much, Peter.
Thanks for having me.
And we've also been joined by Steve Madera. He's Vice President of Global Thermal there at Vertiv as well. Thank you so much, Steve.
You're welcome, Dana.
And a big thank you as well to our audience for joining us for this sponsored BriefingsDirect Data Center Strategies interview. I'm Dana Gardner, Principal Analyst at interoperate Solutions, your host for this ongoing series of Vertiv-sponsored discussions. Thanks again for listening. Please pass this along and share it with your IT community, and do come back next time.